Okay, Bismillahirrahmanirrahim. Dear students, this is a new topic, and the name of the topic is the Class A Power Amplifier. It is taken from Floyd's book. It is chapter number 7 from Floyd's book. Now let's go through the bullet points. Now it says that whenever an amplifier is biased in the Lear region, right, and where the output signal is an amplified replica of the input signal, then it is called class A amplifier. So if I draw a picture of this bullet point, so I can say that if I have an amplifier, right, and I have the input and the output, if I apply a signal at the input like this one, okay, and at the output I can see over here this will get amplified. So if you see the output, the shape of the output is same as the input signal, okay, this is the input signal, remember, but if you see it is amplified version of the input signal, right? So by shape means, by replica means that if you see the output signal has two cycles, right, the positive one and the negative one, right? Okay, so this is an example of class A amplifier. Now what else? The second point says that the discussion of amplifiers in the previous chapters apply to class A operation. So whatever we discussed last time, it was regarding class A operation, class A amplifier operation. Why? Because we were seeing that the output, as I shown you earlier, the output was not distorting, and it was exactly following the shape of the input signal. Now power amplifier are those amplifiers that had the objective of delivering power to a load. So basically if you see we have previously the discussed amplifiers were small signal amplifiers, which were mainly concerned with the voltage amplification, voltage gain, current gain, right? So we never focused, though we discussed the power gain, but we did not went thoroughly in the power ratio or in the power gains, or the power dissipation, or the power delivered to the load. So because those were small signal amplifiers, now in power amplifiers we are main concerned with the actual power rating or the power capability of an amplifier. So this is how we say we should be looking, or focus should be delivering power to the load. Now this point says in a small signal amplifier, the AC signal moves over a small percentage of the total AC load line. So this is a point where we want to differentiate between a small signal amplifier and a large signal amplifier. So a small signal amplifier basically it operates on the DC load line, okay, and the signal moves around the quiescent point, right? Okay, so if I draw, remember this was somewhere, remember this was our Q point, okay, this point was our Q point. So the signal was, okay, the signal over, this is, if you draw the signal over here, so basically you will see that the signal, it was VCE, okay, and this signal was supposed to be like it was IC signal. So the signal it moves over the small percentage of the DC load line. So the movement for a small signal, actually what happens that its movement is very close to the quiescent point, okay. So the variation of the output signal, we can say, is near about the Q point, okay. Now when the output signal is larger and it approaches the limits of the AC load line, the amplifier is a large signal type. So what happens that if I increase, okay, the input signal by such an amount, okay, if I increase the amplitude, right, so definitely, and this is the DC load line, remember this one, if I write, this is some, okay, this is like, this is my Q point, okay, remember this is my Q point, Okay, this is the IC current, this one. Okay, this one is the IC current. So you can see that now if when this signal increases amplitude, so now it will vary, okay, around this or around this Q point, okay, by higher percentage. It means that it can reaches saturation over here, right? Okay, this point is saturation and this point is your cutoff. Okay, so it can be limited by these 2 points. So whenever we apply or we increase in the input, in the magnitude of the input signal, that's why we call this as a large signal type, okay, which is always limited by, okay, by these 2 points, which is uh, the cutoff and the saturation. Okay, now class A power amplifiers are large signal amplifiers with the objective of providing uh, power rather than voltage to a load. So by definition we say that class A amplifiers, okay, these class A amplifiers, these are large signal amplifier, these are large signals. Okay, so you can say that now this is, we know that this is large signal, and whenever we say large signal, so definitely it implies that we are dealing with some power rating. Okay, so it should be power amplifiers, right? Okay, okay, this should be power amplifier. So we should be looking into its power aspect rather than voltage or current gain, right? Okay, now next slide. Now if you see sorry, now if you see, this is an amplifier over here, right? And we can say that, let's suppose, okay, so this is a signal, the input signal is applied, okay, we received or we get an output signal over here. So is the, if you ask some questions regarding this amplifier, right? Okay, so the first question it can be asked, that is it class A amplifier? So we can see, we can say yes, this is class A amplifier, because the output signal, okay, this output signal, it retains its original shape, okay, as in the input signal. But this is class A amplifier, so we can say that this is class A amplifier actually. Okay, this is, I can write this as class A amplifier, right? Okay, now the next question is it a small signal or a large signal amplifier? So we can say that we don't know about if it is a large signal or a small signal amplifier. Why? Because we don't know about its variation, right? Okay, its variation about its Q point, remember? Okay, so if it is being affected by this saturation and cutoff points, so then we can say this is large signal. Okay, and if it is not affected by the saturation and cutoff, then we can say this is a small signal. Okay, so basically we'll be looking its amplitude and its variation around this Q point. So then we can say about its the small signal or large signal definition. And how it is, it a power amplifier? The third question we can ask, that is it a power amplifier? So we don't know about this fact, because we don't know about the ratings, right? Okay, so normally if you see for a power amplifier, okay, it's half watts, 1 watt, 2 watts, right? So we have different specification for the amplifier. So once we have the specification in power, so normally if this is less than half watt, so we don't call this as a power amplifier, right? Okay, if it is greater than half watt or 1 watt, so we can say this is just, you know, the amplifier is a power amplifier, right? Okay.